And now I like to move into dimensions of sustainability first. And I introduce it by 5 E's: energy, education, economy, environment, ethics. So people sometimes question, Ibrahim, why ethics and not the social dimensions? And I make it very clear that ethics is the shelter, so even covering the social dimensions. So I see it is going to be very critical to study these dimensions. Of course, today my primary focus is going to be on energy, and then we'll get into. When or before getting into, we need to look at and understand what people need. People need 4 things: clean air, clean food, clean water, and clean energy. So this particular item, clean energy, affects each of these above. So really, water, food, air is quite affected by the cleanliness or uncleanliness of energy. And then we are now in an era we need to change our energy diet. So from a junky food into a healthy diet where we have the renewable energy sources really deployed. And I like to get into, of course, more and more now. And I have this perspective article, and I wrote this just in the beginning of the pandemic in 2020. And then I made it a kind of turning point and really changing the picture, and also a turning point for or from carbon age into hydrogen age. So really making this, and I see, of course, pandemic has brought lots of difficulties and issues and etc. But at the same time, opportunities for energy solutions. And we need to look at the history of fuels. And I always show this based on carbon hydrogen ratio. And when we look at this, to see how humanity has started with the wood, later coal, oil, natural gas. When you look at this trend line, you see we are moving into a carbon-free period. And this particular period is not going to be possible without hydrogen. So the key question, yes, hydrogen can be used as a fuel, and also some people call it a energy carrier, and you can store, use it later and actively as energy carrier. But more importantly, I see even a critical role here as a feedstock. When you have your hydrogen, and especially clean hydrogen, and you can synthesize other fuels and chemicals depending on the path you select, either with carbon monoxide or with carbon dioxide. When we look at the sectors, and really primarily transportation sector, where we use fuels heavily, and then really the sector is crying. And when we look at the world globally, we need to actually treat this. And we see a critical role with the hydrogen to heal the world. So let's look at the global activities around before getting into some specific research dimensions. And of course, hydrogen energy ministerial meeting started in actually back in 2018, and then 2019 accordingly, same in Japan, 2020, and then 2021. So the ultimate goal by organizing this and inviting leading countries to take part for a common goal, really to develop hydrogen powered society. And various countries introduced their really appealing targets, and Japan made it very clear in 10 years, 10 million hydrogen powered systems, including some vehicles, and 10,000 hydrogen refueling stations, etc. And also, we need to look at the world's hydrogen production. And when we look at it, of course, early 2019, and we see here really primarily by fossil fuels, natural gas, crude oil, coal, only we have about 4% by electrolysis. By the way, the electricity is not purely clean electricity. So it is still a fossil fuels based electricity. And then late 2020, and only, of course, increased a little bit, but still less than 5% coming from electrolysis. And when you look at it, is going to be only very small percentage using renewable electricity. And also we do life cycle assessment. It is really critical to look at the life cycle assessment when it comes to hydrogen production methods. And the life cycle emissions, if you try to produce hydrogen out of fossil fuels, you see really still remarkable. And what option is going to come out? And we see here really the bottom part where we have nuclear and renewables. So basically using nuclear heat or electricity, renewable heat or electricity, or in a combined manner to disassociate water into hydrogen and oxygen. So this becomes important. And I make my equation similarly by saying that renewables and nuclear is gonna better survive with the hydrogen energy options. So really where we need innovative solutions related to hydrogen for implementation. Also, recently we have done some publications, perspectives, and commentary, and to look at the Canada's hydrogen related research and development activities, to look at it from the publications point of view, technology developments point of view, patents, and other related activities, and to see how well the universities are doing. And we are really leading in this area in terms of publications, theses, and also other related outcomes. So in my lab, my research portfolio is quite diverse and covering hydrogen and fuel cell technologies, renewable energy technologies, energy storage technologies, hybrid and integrated energy systems, hybrid and electric vehicles, pure electric and hybrid electric vehicles, alternative fuels and production technologies. So these are overall covering my research portfolio. In regards to hydrogen production, and this was actually my keynote talk in 2017, initially where I introduced 18S concept. And this 18S concept is becoming very critical, especially if we are going to be really dealing with hydrogen production and look at what items will be really critical, and to look at the domains. And really in this regard, and I introduced this 18S concept. And to look at it, of course, you may start, with the safety, scheme, sector, solution, stakeholder. Or if you look at it overall, 18S will be very critical. And of course, this is going to be something very important, and not necessarily only limiting it to hydrogen production. One may extend these to really cover storage, distribution, and primarily the final step, utilization. And we have looked at this and started doing the ranking based on technologies we have developed. And the ideal case, if we take this ranking between 0 and 1 is going to be sort of ideal case, and 0 is going to be the worst, and then trying to look at all these and then accordingly do the ranking. If we try to look at the technologies, and we have done it for various technologies. This is just an illustration and covering one of the assessments, and to look at it this way. So we have been developing technologies. This is in my lab, and really trying to cover as many of these items effectively and efficiently. At the same time, hydrogen hub development is very critical. And I led a project, and this particular project was really related to a feasibility study on the development of Oshawa Hydrogen Economy Hub. And the prime purpose was really under 3S: source, system, and service. Source, and we looked at what sources potentially we have got. Nuclear, especially in Ontario, specifically in Oshawa, and then also additionally renewable energy sources. And then we looked at the technologies as we have developed, and really to be able to use in this particular case, and really developing the hub. And the key requirement is going to be really hydrogen production, and then also producing hydrogen and supplying to various sectors. And then looked at this and started doing the feasibility studies, and also compare with other options, and renewable hydrogen, nuclear hydrogen, and using the existing grid electricity to do the electrolysis and compare that way. And also, of course, the base case will be with diesel. And when it comes to, let's say, transportation sector, and especially public transportation, because they needed this solution, and we have looked at it. We have looked at it, and really having the university primarily responsible for hydrogen production, and also using various technologies as we have developed, and also really supplying to transportation sector. And that was, of course, primary purpose. And again, as mentioned, the sources was nuclear and renewables, and also, of course, the existing grid and grid electricity was also considered in terms of comparisons. And also similarly to look that really consider four cases, diesel bus, public transportation, compressed natural gas, battery electric bus, and fuel cell electric bus. So technically, of course, which one is making it the most environmentally benign, and the fuel cell electric one is making it the most environmentally benign. But economically is not better than battery based on the current prices. But now the target is going to be really $2 by 2030. So eventually, this is going to be more cost effective. Also, studying various options, because sector development is very critical. And I have carried out a specific project for the government to look at the hydrogen sector development in Canada. And this particular item was really to look at various domains and look at the, of course, production pathways, utilization sectors, storage distribution, and the roadmap, really making it short term, mid term, long term, as Canada decided to be carbon neutral by 2050. So this is really important, and accordingly developing the roadmaps. And then changes required, of course, policy related, education related, economy related, etc. So becoming very critical. Looked at the sector development, and also hydrogen production and distribution is becoming another important, including, of course, delivery and dispensing cost, and looked at various cases countrywide to be able to see how much additional cost because of the delivery going to be coming into the picture, and how much the price is going to be affected by this. So these are giving you some additional figures in terms of compressed hydrogen or liquid hydrogen. And then what about the delivery distance from 100 kilometer to 500 kilometer? So to consider and compare. Additionally, a recent study to develop the hydrogen farm concept, and I did it for Turkey in terms of a specific application and countrywide case study to look at the renewables. So we have the renewable energy sources, and then potentially using the technologies as we developed, and then producing hydrogen and really utilizing it in the sectors, of course, in the various sectors of the country. And this is, you see, and doing it for the country itself to look at all renewables, from solar to wind, geothermal, hydro, even including large and small, and using wind onshore, offshore, and also even marine, and even undersea currents, to look at it overall for every location and every city. 81 cities exist in Turkey, and look at it, including even biomass option with wastes. So these wastes are considered as well. And then looked at it, and they found out that annually we have a kind of production capacity as 614.21 million tons of hydrogen, and to produce by using the excess power and energy available through various sources, and doing it for all cities. And these are becoming top 10 cities in terms of hydrogen production potential. Also, I led a project, and this particular project was a kind of unique in terms of producing renewable hydrogen by using wind and solar together, and then producing clean hydrogen. And the ultimate goal was really to blend with natural gas, and develop this project with a partnership, of course, of Gazbir, Gazmer, and also supported by the Ministry of Energy and Resources in Turkey. So doing the pilot study and mixing hydrogen with natural gas, and conducting the performance tests and emissions tests in this regard, and do the evaluation. Of course, the results were quite encouraging. You may wonder in what percentages, and doing it by volume, mixing hydrogen with natural gas up to 50% by volume, and also looked at the various additional options, renewables, and also gasification, where we have the wastes available, even with thermochemical cycles, bringing them into this, and doing these studies as well, and we have published them. In my lab, additionally, we have been looking at the other additional options. This is one integrated cycle. We have had a large consortium, and to study and develop copper chlorine thermochemical cycle for hydrogen production. And this was with a partnership, of course, with the Atomic Energy Limited Canada. Later, the name became a Canadian Nuclear Laboratory, and then developing this. And then also, of course, developing photoelectrochemical methods for hydrogen production, and developed 18 innovative reactors. And I have a solar simulator and solarium in my lab to look at the aluminum water chemical reactions. And the prime target was how to use waste aluminum for hydrogen production. This was something additionally developed. And then also new ammonia fuel cells, and really developing these cells and stocks in my lab, and also integrated energy systems, and primarily targeting even communities, and where we have really in this particular case to cover nuclear and renewables together, and bringing them into to solve community problems, and also not for supplying energy in terms of, let's say, power, heat, cooling, but also additionally fresh water, even food, and depending on, so really from greenhouses to fish farming. And develop one particular project for an indigenous community, and really Aboriginal community, and targeting this Nunavut territory, and where we did this with small modular reactors, and developed this study. And then also high temperature electrolysis is very critical, and we have been developing the technologies. And this is a very important, very effective, very efficient hydrogen production method, and suitable for, of course, in this case, with the nuclear, where we have high temperature heat, even with the solar, where we have high temperature heat as can be utilized in this. Also, another important topic, and we have been working and developing technologies. This is something more mechanical, using ultrasound or ultrasonic sources. And really, what we do and normally develop this kind of wastewater treatment, taking the wastewater, for example, textile, and we can do, of course, treatment here ultrasonically, and more importantly, we come down here and we clean the water, and then later produce hydrogen by using ultrasonic waves. So basically, sound waves to be able to disassociate the water molecules into hydrogen and oxygen. And also, we have discovered something very interesting, and that discovery was so carbon dioxide was really increasing the production efficiency. That was very interesting, and we published that particular item. And also to look at the because when you have hydrogen in hand, what you do, you go one more step ahead to look at other solutions. And we have, of course, renewable energy sources producing hydrogen. And what to do, we separate the nitrogen from air, and then synthesize hydrogen and nitrogen into ammonia. Developing these, and we have commercialized even some critical technologies, and really serving various sectors. As everybody knows, ammonia is extensively used in various sectors, from agricultural to refrigeration, even other chemicals area, so really heavily utilized. And then I have my actually two last slides. And one is related to hydrogen sector development. And I see people are questioning the high, the cost for hydrogen energy systems. And this is gonna be going down, by the way. And when you look at it, the market share is gonna increase. And when you look at here, hydrogen production cost, we did the renewable energy system producing clean hydrogen. So it was about, let's say, 16 Canadian dollars. And we are really targeting to reach down to $2 by 2030. And I did this comparison with gasoline. Gasoline is right now in Canada $2, and because of the carbon tax, other things, and there will be other penalties included. So expected to have the cost by the year 2030 going up to $16. So this is the picture is going to be really reversed that way. And then finally saying, and really sustainable development is very critical, and we need clean energy solutions, and clean energy solutions will require nuclear and renewable energy options considered, especially for hydrogen economy. So the hydrogen economy is going to be really very critical in this. And also we should keep in mind developing hydrogen hubs and hydrogen farms will be very important, and also necessary. Clean fuels. And when we have hydrogen, we can use it as a feedstock to be able to produce other clean fuels, such as methane or natural gas, renewable natural gas, methanol, ethanol, ammonia, DME, and many other types of fuels and chemicals. And at the end, we really need to develop clean community energy system. So we need to look at community-based solutions. So these are going to be very important, and I think it is right time to stop and entertain any questions you have got. Thank you.